Okay, you can use that screen on this one. I don't know what's happening with this. Morning. So today we are looking at section. So let's go to section 6.9.6. During our review, we can still come back to sections 9.5. Section 9.6. So here it is the graph quadratic functions using properties. Graph quadratic function using properties. So a quadratic function, so definition, quadratic function where A, B, and C, where A, B, and C are real numbers, and A is not equal to 0, and A is not equals to 0, is a function of the form, is a function of the form, is a function of the form f of x equals to ax squared plus bx plus c. So a quadratic function where a, b, and c are real numbers and a is not equal to 0 is a function of the form f of x. This f of x is the same as y. So the f of x is the same as y, is ax squared plus bx plus c. And this a is not equal to 0 for it to be a quadratic function. Now, if you want to graph this quadratic function, then we do it the same way we did the other functions last time, where you look for the intercepts, right? You look for the x and the y intercepts. So here, we are going to look at something we call the axis of symmetry and the vertex. But before that, there is something we call the parabola. Now, if we draw the function f of x equals to ax squared plus bx plus c, if we draw a graph of this function, then it forms what we call the parabola. It forms a parabola. Forms a parabola. And this parabola is of the form this. It can be facing down or it can be facing up. Can be facing down or facing up. Now, if A is greater than 0, if A is greater than 0 for this function f of x equals to ax squared plus bx plus c, if A is greater than 0, that means if A is positive, if A is positive, then the parabola opens upward. So the parabola opens upward. So it will be like this. So it will form a curve or a graph like that. Now, so this is one point, another one, if A is less than 0, if A is negative, then the parabola opens downwards. The parabola opens down. So it should be like that. It will open downwards. For example, a function f of x, if you're given a function f of x equals to minus 3x squared plus 2x minus 4, then as we can see from this, A is equals to what? Minus 3, right? So A is equals to minus 3. So what will happen here? It will open which way? Downwards, right? So it will face down. Now, if the function b, if this one, f of x equals to 6x squared plus 7x minus 9, then A is equals to what? A equals to 6. So A equals to 6. So what will happen? It will go which way? Upwards, right? So it will form like that. So this is like this. So that is the shape of our graph. So that will be our shape of the graph. So first of all, we will look for, when we go to the section where we are drawing the graph. So our first step is looking at the value of A. How will our graph look like? So will it face down or it will face up? So you start by looking at the value of A. So at our point here, before you even draw the graph, so you'll know that this one is facing downwards and this one is facing upwards. Any question up to there? Now let's come to how to find now what we call the axis of symmetry. The axis of symmetry. And vertex of a parabola. The axis of symmetry and vertex of a parabola. So when we talk of symmetry, I think you've done statistics, right? At some point, maybe you've done statistics. When you have something like that, a line like this in statistics, if it is like that, yeah? You remember this? And then this one was mu. This one was the mean, right? So if this side is similar to the other side, then it is what? Symmetric. But if it is skewing, there is something we call skew to the left and the skew to the right. You remember that? Maybe you did not do statistics. So if it is coming this way, and then that this is still symmetric. So this side is similar to this if we bisect that line like that. Now, coming to this, now for our quadratic function f of x equals to ax squared plus bx plus c, then it will become symmetric as well. Because if a is equals to, is greater than 0, then if this is our y and this one is our x, yeah, so definitely you form like something like this, yeah. So when you draw a graph, you will form something like this, okay. Now, if you form something like this, then if you bisect this line at the middle, then you can see that this side is similar to the other side. So it is now symmetric, okay? So when it is symmetric, then there is something we call the axis of symmetry. The axis of symmetry is this line here. Is that line, the line which is bisecting this graph here, okay? So how should we get the axis of symmetry? So to get the axis of symmetry, I don't want us to go so much into that. What we usually do at this point over here, the value of y is equals to 0. That means what you do, you find the derivative of this, f of x, to be equals to 2ax plus b. Because I don't know whether you've done calculus, right? So this is equals to 0. Now, if this one is equals to 0, then we need to get the value of x at this point. So the value of x at this point is now we take all these other values to the other side, which will be equals to what? So it is 2ax plus b equals to 0. Now 2ax equals to minus b. Now to make x the subject, then you divide everywhere by 2a. So x equals to minus b all over what? 2. So here now, this is what we call the axis of symmetry. So this is the axis of symmetry. So leave alone with this. So let's just use this formula as the axis of symmetry. Now, if you're asked to get the axis of symmetry, then this is the formula. X equals to minus b all over 2a is the axis of symmetry. Now, you know the values of x, you know the values of a, and you know the values of what? So you now come there and substitute there. So you just substitute here. So now the function f of x equal to ax squared plus bx plus c, the axis of symmetry is x equals to minus b all over 2a. X equals to minus b. So make sure you remember this. X equals to minus b all over 2a. So b, you get it from here. A, you get it from here. And then also you make sure that you consider the what? The signs. So if it is a minus, then don't forget to put a minus. If it is a plus, then don't forget. So mostly minus can confuse you. So don't just take the value of p. So you must consider the signs. So this axis of symmetry, as I told you, is where now it is a line now at this point. So because we say the axis of symmetry is what? X, right? So it is this line, X equals to what? Any line there. So it can be here. So it can be of this form again. So it can be of that form. So where is X? X should be there. So this axis of symmetry now, from this point, from this, let's say we use it, from this point here, yeah, to this point is similar from this point to this point, okay? From this point here, this line here, which is the axis of symmetry, to this point here, yeah, is similar to up to that point, okay? So if you are now drawing, if you now want to draw this graph here, as long as you've gotten the axis of symmetry and you want to get the harder point of the line there, then you can now consider if you've gotten the value of y, let's say the value of y is somewhere here, and now you know this point, which is the axis of symmetry. Then to get the other points, you go same distance to the left, and then same distance to the right. I will show you how to do it. Okay, so that is the axis of symmetry. Now let's come to the other one, which is called the vertex. The vertex is a point on the axis of symmetry. So the vertex is a point. So it is a point, vertex is the point in the axis of symmetry. And the axis of symmetry we said is what? Minus b all over 2a. The axis of symmetry is minus b all over 2a. So what is that point when x is equal to b minus 2 all over 2a? So you now substitute the value of this, which is x, to this, so that you get that point, okay? All right, so, and the y coordinates of the vertex is found by substituting the x equals to minus b over 2a into the quadratic equation. Now, example number 1. F of x equals to 3x squared minus 6x plus 2. So the question is, find the axis, so find the axis of symmetry. And then number 2, the vertex. Find the vertex. Now, the axis of a symmetry, so the solution. Now, to get the axis of symmetry, then we know that x equals minus b over what? All over 2. X equals to minus b all over 2a. Now we know the value of a here is equals to 3, right? And the value of b is equals to what? Minus 6. Value of b equals to minus 6. So our axis of symmetry, we now substitute these values here. So x equals to minus b is minus 6 all over 2 times a is 3. So when you open this bracket, then what do you get? So this is 6 all over what? Which is equals to 1. So that is our axis of symmetry. Now, how should we get the vertex? Like the vertex, I mean. The vertex, and we say the vertex is the what? Is a point in the axis of symmetry minus b all over 2a. Now we know x equals to 1. And we know our function f of x equals to 3x squared minus 6x plus 1 plus 2. Now, how should we get the point? And I say this f of x is similar to y. So how should we get the point? So we now substitute the value of x to this equation here. So we now get y equals to f of, we know x is 1, right? So it will be f of 1 equals to, where there is x here, we put 1. So 3 times 1 squared minus 6 times 1 plus 1 plus 2. So this is equals to 3 minus 6 plus 1 plus 2, which is equals to what? Which is equals to, so 3 plus 2 is 5. 5 minus 6 is minus 1. So minus 1. So the vertex in our case will now be 1 minus 1. So that is our vertex. Now, our vertex is this point. Our vertex is this point here. So this is our vertex. Our vertex is also this point here. Vertex. Okay? So at this point here, this is the vertex. So that is a point where the graph will curve. All right, so that's how to solve, to get the axis of symmetry and to get the vertex. Okay, now let's come to the next property. Now, how should we find the intercepts of the parabola? Intercepts of the parabola. How should we find the intercept of the parabola? Now, to find the intercepts of parabola whose function is f of x equals to ax squared plus bx plus c. So to find the intercepts here, so definitely we have the y-intercept, and then we have the x-intercept. So we have the y-intercept, and we have the x-intercept. Now, for the y-intercept, then let x to be equals to what? 0. So for the y-intercept, you let x to be equals to 0. And then you now solve, you solve f of what? F of x. Now you solve f of x. Now, to get the x-intercept, then y should be equals to 0. That means this y is what? F of x should be equals to what? Should be equals to 0. So f of x should be equal to 0. And then now you solve what? You solve x. Then you solve x. Now you find that when you're solving the values of x here, because it is quadratic, then you get the form of ax squared plus bx plus c equals to what? Equals to 0, right? Because we say f of x is equals to 0. Now, to solve the values of x, then you use the methods that we did. Either you factorize, either you use the completing squares, or you do what? Use the quadratic formula. So use the quadratic formula. Now, at this point, we can still use the discriminant. You still remember the discriminant? And this discriminant is b squared minus 4ac, right? The discriminant was b squared minus 4ac. Okay. Now we can use this discriminant to get the values of what? How many values of x should be there? Now, if b squared minus 4ac equals to 0, if b squared is equals to 0, then what we get here, the value of x will be only be what? 1. So it will only be 1. Okay? So it will only be 1. And that, if it is 1, then if you're drawing the parabola, then if it is only 1, then it can be at this point, it can be here. So our parabola will either be like that, okay? So it will either be like that. So it's only 1 point, okay? So it will just be here. Or if it is negative, then it can be somewhere there, okay? So because it's only 1 point. So our parabola will be 1 point like that. So it, because the value of x is only 1 there. So it will be of that form. Now, if b squared minus 4ac is greater than 0, if that one is greater than 0, then we'll get 2x values. So our parabola will be now be of, let's say that form, okay? Because we have 2x values, this one and either that one. Or it will be anywhere here. Or it will be like that, okay? Because we have how many points? 2x values, okay? But now, if b squared minus 4ac is less than 0, if that one is less than 0, then if we remember, we were getting the complex values, right? So in this case, we will note there is no x values because the x values are not real. So there are no real x values there. So you will not get the x values because they will not be real. So if they are not real, then the Because we don't have the x values, then our graph will be outside there. So it will go maybe outside that side. So it can go outside here because it's not touching anywhere within that line of text. Okay. So in your homework, I know you'll be asked such a question like this. Now you need to know if you have, so you need to check using the b square minus, using the discriminant here. If it is less than 0, then definitely you don't have the axis of symmetry. Okay, so you not get the axis of symmetry because the x values are not real. All right. So let's do one example on that. For example, find the intercepts of the parabola. Find the intercepts of parabola whose function is f of x equals to x squared minus 2x minus 8. F of x equals to x squared minus 2x minus 8. So let's start from the y-intercept. The y-intercept. So for the y-intercept, then what do? You let x to be equals to what? X to be equals to 0. X equals to 0. So you let x to be equals to 0. So if x equals to 0, then y equals to f of 0 equals to what? 0 minus 2 times 0 minus what? Minus 8. Minus 8. So our point here will be what? So we have y equals to minus 8. So our point here will be 0 and what? Minus 8. So that is our point. Okay? So that is our y-intercept. Now, to find the x-intercept, now to find the x-intercept, then what do? You let y to be equals to, or you let f of x to be equals to what? To be equals to 0. You let f of x to be equals to 0. So our f of x there is 0, so it will be x squared minus 2x minus 8 equals to what? Equals to 0. Now, looking at this equation here, quadratic equation here, we can simplify, right? It is easy to simplify this. The product is minus 8 and the sum is 6. So what are the two numbers? So we can take what? It's 4 and what? 4 and 2, right? So x squared minus 2x minus plus 4x is plus. So plus 2x minus 4x, right? Minus 8 equals to 0. Equals to 0. So here, x plus 2 minus 4 x plus 2 equals to 0. Now, using the zero product property, then x minus 4, then x plus 2 equals to 0. So we have x equals to 4 or x equals to minus 2. So our x-intercepts here will be what? 4 and 0, right? And what? Minus 2 and 0. So those are our x-intercepts. Another example. Find the intercepts of the parabola for the function f of x equals to 5x squared plus x plus 4. F of x equals to 5x squared plus x plus 4. So to get a y-intercept, so you start by y-intercept, then definitely x equals to what? Equals to 0. So when x equals to 0, then y equals to f of 0 equals to 5 times 0 plus 0 plus what? Plus 4. So y equals to 4. So our point there, the y-intercept, is what? 0 and 4. Our y-intercept is 0 and 4. Now, how should we get the x-intercept? So how should we get the x-intercept? So our x-intercept is when y equals, when f of x equals to what? Equals to 0. So our f of x there is 5x squared plus x plus what? 4 equals to 0. So we have the product there is 20, and then the sum is 1. So are we going to get any two numbers where the product is 20 and the sum is 1? So if you use 5 and 4, yeah. So we can still use 5 and 4. Now, but here, let's do what? Let's use b squared minus 4ac. Let's see whether this one will give us two solutions of x, okay? So our a equals to 5, our b equals to 1, and our c equals to 4, okay? So b is 1. 1 squared minus 4 times a, 5, times c, 4. So 1 minus what? So this one is it 80? So what are you getting? Is it a negative, right? So this is a negative. So this is less than 0. So that is less than 0. So therefore, since the value of discriminant is negative, so since the value of the discriminant is negative, then there is no real solution to the equation. So since the value of the discriminant is negative, then there is no real solution to that equation. So there is no x intercept. There are no x intercept. The time is moving so fast. Huh? All right, so those are the properties that we will need to use now to draw the what? To draw our parabola, to draw our quadratic equation. So these are the properties. So what we need to do is, so there are steps of drawing. So graph quadratic equation or function using properties. First of all, what you do, you need to identify whether it is facing upwards or what? Facing down by looking at the value of what? A. Okay, so that's the first step. The second one, we get the axis of symmetry and what? And vertex. Okay, then the third one, you now get the what? You now get the y and the what? And the x intercept. So the moment you get all these, then you are now able to do what? To draw the graph. So on Wednesday, we'll come and do this one. Then also, I think our next quiz will be in Newton, okay? Because your exam, you will do it in Newton. And make sure you remember the date for your exam. Do you remember? So the exam is the last Monday of this semester. I think so. I think it will be on these dates. I think from 3 to 5 p.m. You need to check this. Please confirm this one, okay? So that you don't miss your exams. All right, we'll still discuss about that when we meet again. So before you go away, Avalos, Benjamin, Gregory, are you online? Adam is here. Ashley. Victoria. Rachel. Bailey. Laura. Adam, you can see Adam there. Kavehi. Andrew. Destiny. Ali, Abby. I think I saw Abby. Aliyah.
I'm on Zoom.
Okay. Aldo. Jillian. Remington.
I'm on Zoom.
Milton. Rayleigh, Eric, Kayla, Rock, Samuel, Workman. All right, see you on Wednesday.
You have a good day.
You too.
So that would be that briefing day, that would be the day of our final exam?
Yeah, that one is the day for your final exam. I think it will, yeah.
Okay. And then, like, I was looking at Newton, and like, our last assignment is the 18th.
Mhm.
Will we have class after that assignment is due?
The 18th?
Yeah, because like, the 8th, that's like the week before,
Oh, you saw an assignment?
like, so like, the last assignment is due this day, the 18th.
Mhm.
And then this is, like, we
The
would have
final
class,
is-
like,
yeah,
we
we
would have
still
class
have a
that,
class.
we'll have class that day after the
I
last
think it will be
assignment?
just be revision or something like that.
Okay, so we still will have class and come in here?
I think I might extend some of the homeworks here.
Okay,
Yeah, because this one is, I think this one is the last day of our class. Because from,
the last in-person class is this Tuesday.
oh, Tuesday, right?
Yeah,
So
so our
your-
last class would be that Monday.
The last class is Monday. Yeah,
Okay, so
yeah.
we'll still have class that day?
Yeah, we will come to
Okay,
class.
I just
It will
wanted to-
just be revision
Okay,
for our finals.
and the finals that 30th?
Yeah,
Okay,
the final is the first week of finals.
okay, and
Yeah.
we'll do it on Zoom like we did last time?
Yeah, we'll do it on Zoom. So I will still give you some details on the same.
Okay,
Yeah.
perfect.
All
Thank
right,
you.
see you.